Hi guys, welcome back to my channel. Today we're going to be talking about controlling body temperature. This is a sort of sequel from my previous videos. So I recommend watching homeostasis, the nervous system reflexes before, just to give you more of an idea. You don't have to, but this will make more sense to you this way. My whiteboard's clean for once because I found out this new technique on cleaning it, but I'm still going to I'm still going to sue this company, Sadler, for making whiteboard pens that don't rub off the board. But I'm going to do one, I'm going to do one rub off in the middle. I'm limiting it to one this time because it's a waste of time. So, controlling body temperature, very, very important. We have an optimum body temperature of 37 degrees inside our body. It's very important that we keep it at this temperature for our enzymes to work. This is the optimum temperature for our enzymes to work properly. And your enzymes carry out all of your reactions in your body, so without this perfect temperature, then your enzymes wouldn't work and you wouldn't be able to live. So if it's below 37 degrees, your enzymes will work, they'll have a slower rate of reaction. If it's above 37 degrees, the enzymes will denature because it will be too hot. So your body must be kept constant, and to do this, it needs to balance out the amount of energy lost and the amount of energy gained. If you lose more energy than you're gaining, then your body temperature will dip below 37 degrees, and if you gain more energy than you're losing, your body temperature will go above 37 degrees. So your thermoregularity center it's in your brain. I can show you a picture just here. That part where it's pointing to with the arrow, that's your thermoregularity center in your brain. It's like a little spud thing. This has receptors. Remember us talking about receptors? They detect stimuli. That's how you spell thermoregularity. It's a bit of a long word to say. Receptors. They are sensitive to the temperature of your blood flowing through your brain. So the blood, you obviously have blood flowing through your brain, and these thermoregularity centers will detect the temperature of your blood. They're sensitive to the temperature of your blood, so basically the temperature of you. They will also, so they write it down, receptors sensitive to temp of blood through brain. This is my blood. So the thermoregularity center also receives impulses, it also receives impulses from your temperature receptors in your skin. So as we talked about in a previous video, you have like sensory receptors in your skin, so they will kind of detect the temperature of your skin, and then they'll send this message in electrical impulses. They'll send this message to the thermoregularity center, and they'll be like, you're too hot or you're too cold. So the thermoregularity center will receive impulses from the temperature receptors in the skin, and giving the thermoregularity center information about skin temperature. this happens. Don't worry if you don't understand this. We're going through. This is like a little station. Let's just say that this is like a station, and the blood's flowing through it, and it's just like, yep, right temperature. Nope, too hot. Yeah. So, so this works in a negative feedback loop. Remember our negative feedback loop? It counteracts change, it brings it back to normal, and this works in the same way. So basically, the temp receptors.
Music on still.
What?
Music?
That doesn't matter. The temp receptors, these are the first part of the feedback loop. Well, it's a loop state, but anyway. Detect, core temp, and they're like, it's too high, for example. Wait, my mum's just coming past. So they'll detect that it's too high, the temperature, and then this message, they'll detect that it's too high, and then they'll send this message to the thermoregularity center, which is the coordination center. Do you remember we talked about the coordination center, the brain or spinal cord? So the thermoregularity center is in the brain, and so that it will receive the information. Receive information. Can you read that? Sorry, I just looked in the camera, but that says receive information from the temperature, from T receptors and triggers. Effectors. So remember, it will decide what to do. It will get the information that the core temperature is too high, and then it will decide what to do. It's the decision maker. It will organize the response, and then it will send this information to the effectors, who will actually produce the response. They actually, they do the deal. Oh, you can't see that. So the effectors, for example, the sweat glands, we'll go through that a bit more detail in just a second. Sweat glands, they'll produce a response. So they're just told what they should do, and then they'll do it. They'll produce the response, which will counteract the change. So it will because it's too high in temperature. The counteracting the change will make it lower. So it will do what it needs to do to make the temperature lower, and we'll talk about that just a sec, of what they'll do to make the temperatures lower, like what the effectors will actually, what response they'll that will take place in order to decrease the temperature of the body. We'll talk about that in a sec. And then the body will cool down. And then this works in a loop, obviously. So then if the temperature detect that the body temperature is too low, so we're rewriting it now. So the temperature is too low. They send the message to the thermoregularity center, which acts as the CNS, and it will receive the information from the temperature receptors and trigger the effectors automatically. It will automatically send this information to effectors. The effectors, for example, the muscles, which we'll talk about in just a second, they will produce a response and counteract change, and then the body temperature will warm up. So, does everyone understand that? Now, so we said that the body temperature. We're going to try some wipes, see if this helps get this in. So we said that the body temperature. So we said that it. Oh, can everyone? Happy days. So, we said that the effectors produce a response, and this response will either, to keep our body at this perfect temperature, the response will have to, the response to take place for if we wanted to increase our body temperature or if we wanted to decrease it, and we'll go through what responses they are. So, for example, if you're too hot, let me just. So, if our body temperature is too hot, for example, we're in a really hot room, it's a really summer's day, we've just done a lot of exercise, the first thing that will happen is that your hairs will lie flat. These are things that you would notice on yourself. So this is our skin surface. This is like a skin cell, for example. Or, no, not skin cell, but this is like a surface of our skin. Your hairs, they'll just lie normally like this. That will come from a root. Another thing that will happen is that sweat is produced. So you might be thinking when you sweat, why the hell does this happen? Like, this is gross. We're like leaking gross smelling water, but it's actually in order to cool you down. So sweat is produced by the sweat glands, and then it will evaporate. So the air around it will cause it to, the water, because sweat is water, and it will cause the air around it will evaporate the water on your skin, and with evaporation it will mean that you will transfer energy to surroundings or to the environment, which would cool the body down. So sweat glands, we have sweat glands just here, and they'll cause like sweat, that's like gross sweat, and then the energy will transfer into the surroundings and it will leave your body, which will cool you down. Another thing that will happen, which is quite interesting, is a thing called vasodilation. So this basically means that your blood vessels supplying the skin capillaries. Make sure you're copying this down on anything, a piece of paper or whatever. I think I just spelled capillaries wrong. Oh well. Supplying the skin capillaries. So your blood vessels supplying the skin capillaries will widen or dilate. So more blood flows. Surface of skin. So, for example, let's just say it goes like this, and this is a wider blood flow to the skin. This will cool the body. I'm going to write it up here. So it cools the body core, like your core of your body. It will cool your body down, and transfer energy from the skin to the environment. So basically, if these are wider, more blood can get to the surface of your skin because it's wider. More blood can get through, which means that there's more heat. Which means that there's more heat in the surface of your skin, which obviously means there's less heat in your core, and because all the heat will be going to your skin, which will transfer to the environment. If most of your heat is concentrated at your skin, this is better because it will transfer to the environment. It's this quickest route to the environment, to your surroundings through your skin. So in order to cool your body down, your effector will produce a response of widening your blood vessels to get all this, to get all your blood around near your skin, which is probably why you'd feel like your skin would feel really hot. Gets all your blood to your skin, so then it then escapes to the environment and leaves your body. So if your body is too cold, it basically produces opposite sorts of reactions. So your hairs will stand up. This is why you get goosebumps or just erected hairs or whatever. Stand up to, but this is to trap insulating air. So think of it as like a coat, so they spike out and the air will get caught in it a lot more than if they were to be flat. The air will just pass over it, but if your head stand up on end, it will actually trap insulating layer of air. So it would be like a warm layer of air over the top of your skin, trapped in these hairs. So that will keep you warmer. So if I draw a little diagram here, this is the surface of your skin. Your hairs will be, they'll be on end like this, and the air will get trapped in them. You will also not sweat. You don't want to lose energy. That's the most important thing here. You don't want to use energy, so you won't sweat because you don't want energy to be transferred to the environment for evaporation. You do a thing called vasoconstriction. So you can probably imagine what this is. It's basically your blood vessels supplying the skin capillaries. Am I writing really slanted? I feel like I am. Skin capillaries. Sorry, I just like went into a daydream for a second. Constrict. So they will like close up, or they'll get thinner. So they'll do the opposite of vasodilation basically, and this will close skin's blood supply. Oh my god, I've written this so hard. I hope you can read this. This said blood vessels supplying skin. The blood vessels supplying the skin capillaries will constrict to close the skin's blood supply. So it will, sorry about that, bless me. They'll be like this. They'll be a lot thinner. This will keep core warm. And prevent energy transferring to so if they're wider, less blood can reach the surface of your skin, basically, which is good because you want to keep all that warm blood in the center of your body to keep you nice and warm, and you don't want to lose it, and you don't want your energy to transfer to the surroundings, which it will if all your blood was concentrated to your skin. And the last thing that you do is you shiver. So yeah, you do shiver for a reason. It's basically your muscles contracting automatically. So this needs respiration, for energy. And respiration transfers energy, some energy, not all of it. Energy goes to all different places. Ow. Body. So when you shiver, your muscles will contract, so you'll respire, respiration, and then from respiration, energy is transferred. Some of this energy will go to warm your body. That's why you contract your muscles. Don't know why I can't speak. So that's pretty much it for the end of this diagram. Oh, let's do like a sweat gland here that hasn't produced sweat. And you're also shivering because of respiration. Sorry if I said that. Anyway, sorry this got a bit messy towards the end, but I hope you enjoyed this video. Yeah, that's pretty much it. I'm going to talk about three different types of negative feedback loops that happen in your body to keep a steady body, basically. So go click onto the next video. It will be on something. So,